So yeah, so I think the many of the points that you heard so far do convey this idea that first of all you have to be interested in the area, and that's where we feel that you should have. When we keep saying passion, it's something that comes because over a period of time you have been very interested in that area, and you have recognized that you are interested in that area. So that itself takes some while for you to figure that out, because there are many things that you may read that you are interested in, but there's something that really strikes a chord with you. So then that's something that you pick up. We've also, I think, through this discussion, also indicated that there is a general acknowledgement, both in the student community and people who have already been researchers and so on, that research is challenging. I mean, there is a lot of aspects of it that are challenging. For I think the most important reason for that is also the fact that we are learning about research as we do research. So especially the first time researchers. So when you come in as a student, you actually still may not fully be aware of what all is involved here, and as you keep going through the process, you're learning the process. Whereas when you do coursework, it is something that you have done since first grade or first standard onwards. You have been doing coursework, you do classes, you write exams, you get marks. So that's a pattern that you know. This is a completely new pattern that you're handling, which comes all of a sudden after you do your bachelor's degree or your first master's degree and so on. So this is it becomes challenging for that reason, because you are both trying to work to go through the process and complete the process. And if in the back of your mind the intention was to get a degree, then that is also there ahead of you. But and the whole process of doing it is also something that you're discovering. So that's why that's one of the reasons why it tends to be challenging. And as we also pointed out, there's a lot of routine work that is involved here. Which you should not overlook. It's not like you come in here and suddenly you get come into a research program somewhere, and then one fine morning you suddenly get a bright idea and that's it, your work is done. It never works that way. There's a lot of routine work that goes on that you have to keep working on, and building on all of that routine work, your experience goes up. Your experience goes up, your confidence goes up, your ability to identify insights into that area starts going up. And that is when you actually start making those inroads, which you can look back and say, I was now beginning to do research. So that is the point that you need to understand. So I would say, even when you look at research, and when you say from the perspective of how you discuss it in front of others, when you do experimental work and you collect data, in a sense you're doing the drudgery, that all this hard work that is involved in collecting the data. When you discuss it, when you try to put perspective into it, when you try to say that this is the reason why the experiments gave that particular answer, that is when you're sort of actually doing research. You're beginning to analyze that data and convey something out of it, which is more than just simply saying that a particular parameter increases when you increase some other parameter. So that is just data. But why it is increasing is what research is all about.
An aspect of why we have said also research is challenging is is long-term and cyclic nature of it. So this I have experienced with second year, third year undergraduate students when they come to try to just see, I want to do a research project. What happens is when you start off, there is of course learning and you're doing new things and you might get some good results also. But sooner or later, 3 weeks or 4 weeks down the line, you will maybe either something may not work, or maybe what you thought actually was opposite of what you are getting, and all those things. So that's the cyclic process. So research, so somewhere you will find that there are things which actually are not according to your expectations, and that's where what I found is some of the students who can actually pass that during those phases to fall back on routine, to fall back on your knowledge and try to think of something different, and then pass through that negative and then come up again. So that's a big spirit. That's where it's very, very challenging. You have to persist, as Arun said earlier.
It's all in the mind, and this quote.
Yeah, I think also apt. Maybe to reiterate what Funny mentioned earlier, as you're working through, it's important to keep focused, to stay focused on the short-term part, but not to lose sight of the big picture that you're working towards. And it always helps projecting what you have in the context of the big picture. Where does your result fit in? Is it really fitting into the big picture nicely, or is it really taking you away? And the other thing that I want to mention is, in research, you may start out with a problem definition in mind. And as you are working towards that problem, solving that problem, you may find some other problem which requires probably, or which is of equally important proportion or magnitude, that is probably worthwhile carrying out research in itself, which means that your problem definition is subject to change along the pathway. Of course, at some point in time, for practical reasons, you have to freeze the problem that you're working on. But however, in the first year of your working, the problem definition can change, and some things that you had thought were trivial have really not been addressed by anyone. And you find that there is a lot to work in there, and that can become your own problem of research and so on. So there is quite a bit of flexibility in the initial years, which has to slowly freeze. It's like you start off making ice cream, and finally you have to have a frozen product as an ice cream. You can't really have a liquid state also. There is a molten state, then there is a liquid state, and then there is a solid state. So it goes that way, right?
So some of the things that we have been discussing so far are nicely captured in this quote, which is from J.C. Bose, and it simply says, the true laboratory is the mind, where behind illusions we uncover the laws of truth. So that's the quote attributed to J.C. Bose, and it sort of brings out this idea that we are applying our mind to look at new things in new ways and trying to come up with learning which we can then convey to others. So as we also discussed through this process about the mundane aspects of research, we also had this comment from Abhijit, which was that it is a cyclic process. So often you start off and you feel very happy that your initial experiment started working, and then 2-3 weeks down the road something doesn't work. And I would say that's the biggest difference between what I say an undergraduate student trying experiments for the first time goes through, and say a more seasoned researcher goes through. So a typical undergraduate student going through research or attempting research for the first time gets totally disheartened when the first set of experiments fail. And it really looks like the whole process was pointless, the whole exercise was pointless. Whereas a true researcher who has had experience in the process appreciates that this is likely to happen, is quite comfortable with the idea that his first set of experiments didn't work out, and sits back and then tries to analyze. Okay, we got this and it didn't go the way we wanted. So where have we gone wrong, or where is it that we need to reassess our approach? So that is something that we would like to now discuss, which is dealing with failure, both when you do the work, when you try to present the work, and maybe how other people have had experience with it.
Yeah. So actually, if you look at it, most research methodology scores lay out like a path by which you do your research. You do a literature survey, then you identify your problem, then work on the problem, you solve it, then you publish it, you get out. At least in my experience, I've seen very few problems work that way. Okay, so you kind of identify an area, you start working, you do something, and then you invariably may not make progress. Then you stumble on something else, then you try something else, then you see some other area, you listen to some talk, somebody's talking about that, oh, maybe I try this. So it kind of goes randomly. There's a colleague of mine who put it very nicely. He said, research is a random walk. So when you're walking in that fashion, there will be failure. And of course, you should expect that. I mean, this is not something unknown to people, but dealing with that becomes hard. Maybe in the initial phases, you can deal with it a little bit because you've not really published it. But when you try to publish the work, even there, you will see things will get rejected. First time you submit your work, very high probability it will get rejected because you're trying to convey something to somebody else. The very first time you're writing something, it will happen that way, and you have to be expecting it. The idea is there are two ways to react to it, right? When something gets rejected or something doesn't work, you can get either totally dejected, or you can throw it away, and you'll get totally combative. Say, oh no, this guy is talking nonsense, etc. So you have to hit a nice middle path. You take what is possible. And one great advantage of research, which you can use to get over your failure in many cases, is to change your initial assumptions. You're allowed to do that. This is not a textbook problem where conditions are given and you have to get the answer, right? You can keep changing the questions. So quite often people miss that point. You change some assumption, you change the application, you can change so many things to make even your failure become a success.
I think that was a keyword. Assumption was a keyword ringing in my mind when you were just a few minutes ago. Every research work is based on certain assumptions. There is no research work which is devoid of any assumptions. And what I tell my students is, first be aware of the assumptions that you have made. That is the framework in which you are solving the problem. And also ask yourself whether those assumptions are too restrictive. I mean, it only applies to your mind. and it only that you have conceived of those assumptions, or do you really find many problems falling into this framework? So your assumption should not be too restrictive. As long as that's not the case, then as long as that's the case, that your assumptions are not too restrictive, and as long as your results are consistent with the assumptions, then you're absolutely fine. And I think failures definitely are bound to happen, and they can happen at different stages. Like Andrew said, it could be at the publication stage, or it could be just in your own discovery. As Abhijit said, something completely contrary to your expectation, to your intuition can happen. But remember, there is nothing like success or failure in research. What is important is what you expect and what you have discovered, and taking that into your account and coming up with a solid discovery, with a solid answer to a question. Even saying that there exists no proof for some theorem or for some result is also a great result, right? So that should not be taken in a negative stride. I think failures are very important, but most importantly, what I would say is, when you get a result, to avoid maybe rejections by reviewers and so on, which are bound to happen, I think you should be convinced of your result first. That's the most important thing. Many a times, I mean, we have come across different students. Some students are not sure of the results, and the advisor has to really put in some effort to convince that, yes, this is right. And there are situations where the student, the PhD student, is the researcher, is convinced that this has to be the result, even if the advisor says no. So that conviction of what your result has is very important, and that requires a combination of your intuition and, of course, the procedure that you have followed, and, of course, validation. So there are three things, right? Intuition, and then your discovery and validation. If you have done all of this in a proper way, then you can be convinced about your result, and it's all a matter of convincing the other person, right? But of course, dealing with failures is important, and failures occurring towards what you call as a failure, you should have to first define a failure. But what people call as failure, and if it occurs towards the end of your degree or so-called expected duration, then yeah, it's more difficult to say. And that's where I think advisors play a very critical role in cushioning and in giving comfort and so on, and giving advice in the right direction. In fact, sometimes with just a change of idea, you can convert your failure to a success.
Yeah, and failure can be in various ways. I mean, one example where I had with my PhD advisor was, I was writing some 2-page summary report, and it went through iterations, and the first, second, third, fourth iteration, and then we both again met, and again he pointed out something, and so that's where I had a sense of failing, because I was getting irritated, and that's where he then told me that, look, this is not something to get irritated about. I mean, so there then, if you again persist with it and say, okay, let me learn from whatever is being the process I'm going through, then 7th and 8th iteration, finally I was able to write that report based on what is expected of me for being a researcher. So there again, a sense of failing was there, but somehow I was able to come out of it by persisting.
I also want to add that when we talk of, you send in a paper for publication and then it comes back rejected, and I think there are already a few comments on this aspect. So one of the things you should be open to, I'm not suggesting that you should be overconfident, but one of the things you should be open to is the possibility that the expert who looked at the paper may also not be right. Okay, so they look at your paper with from some perspective, their own knowledge of the field and so on, their idea of what is important and what is not important in that area, their idea of what is possible, not possible, etc. A lot of things they are bringing into the process when they look and evaluate your paper. So when you get a review from a journal which comes from a few different reviewers and whom the journal has approached, it is not necessary that they are always right. So feel free to openly look at the review. When you get the review, even if it says, no, we don't accept this paper, it is not up to the standards, or something is not correct about it, you read it. Don't just say that, okay, 2 out of 3 people said it is not correct, so that means it is not correct. So you make an independent assessment of the report that you have got. Okay, so you look at it, you try to assess it, and then see if that makes sense to you, whether you agree with what they have said, or you feel that they have actually missed the point. In which case you need to revisit how you present your work. You may need to give the right kind of background so that when you send it to another journal, the reviewer does not go into the same tangent. you are preparing them appropriately so that they are directed into your line of thought. So that is the way you need to look at it.
Yeah, and important aspect of dealing with failure also is to be able to talk about it. And I think there are multiple places where such help can be there. So your own friends, first you can talk, your own lab mates or your advisor. And so there is one important point which we'll discuss later on is also to recognize a peer community. So we'll come to that little later in our talk.
Okay, so one point that I want to bring out here is again when you read research papers, and you also as part of this thing that you were told that you should do some literature survey and so on. Often those papers are, in fact not often, always those papers are presented in a very systematic and sequential manner. Okay, so as a first time researcher, when you read those papers and you think of the work that you are doing in the lab, you really feel bad because you are not doing anything in that level of sequence at which they are doing it. Very systematically they have done some 3-4 things. They have systematically identified a specific set of materials which they need to work on, and they have done only 25 experiments. From that they were able to get a very nice pair of graphs. From that they could clearly tell you that one particular region is the maximum. They give you the answer. So that's very nicely presented in a paper. The truth is often in most cases that is not how the work actually happened. So they would have also gone through the same kind of frustrations that you are currently going through. They are trying out various different samples, and many of them are completely giving them tangential results or not at all showing any kind of relevance to the particular parameter that they are trying to explore. So they learn something from it. Maybe they have chosen a system that doesn't work, and so on. They change the system and go on. So in the paper they publish, they don't often tell you that we looked at 45 systems, out of which 39 failed. Only 6 of them were interesting, and those 6, and they don't show you all those graphs of failed results. All of that they ignore. They just show you the 6 that work, and in the order in which it logically leads to the conclusion that they have eventually reached. Okay, so but behind each paper there's a lot of failure in terms of samples that didn't work, in terms of analysis that was wrong, maybe experiments that were wrong, experimental setups that were wrong, all of which is not getting reported. So what you experience in the lab is not new. Everybody experiences similar stuff in the lab. Equipment fail, experiments that go wrong, and so on. We just have to keep working with it. So that's something that
I think the analogy that I wanted to give is when you go to someone's place and that person is presenting you with your new dish. I'm fond of analogies. And you really like the dish, and it's been presented very nicely, ornated, and when you ask for the recipe, there is a list of instructions given in a very detailed and a sequential manner, and you think really that the person followed that. That has come out of experience. That cook will not tell you that there were 10 dishes of this types which were burnt earlier. This is the 11th one that's being presented, and this 11th one is success because of the experience with those 10th ones. And so obviously, nobody wants to present that because sometimes it may not be relevant, and sometimes probably it will put you in bad light. But most importantly, for the benefit of readership and the audience, always the paper is presented in a coherent manner, because you don't want the reader to go through the same torture that you have gone through in discovering this job. So I think it's a very important point that Pratap makes, and you should only read the paper to know what it is saying, but rather not to mimic the sequence in which they actually arrived at, they used to arrive at the results.
That's true.
So which also means that when we read a research paper, we also do not read from the first line to the last line in a sequential manner. We can actually look at what is new there, and what is it that I need to do to validate what that person has done, and then what is it that I can extend. So even the reading of paper is not in the same sequence as it is written, and in very often actually we now need to also think whether we should go through every single detail that is there in that paper to be able to confirm that they are up to something good that I can build upon. So I believe that we take some kind of a phenomenological approach, that is given these conditions, what is it that I need to learn, pick up, so that I can go and validate my hypothesis and then go further in the idea that I want to prove. So in other words, there's something like a black box approach. We don't need to know every single detail, but at the same time, we do not need to also brush away the importance of details. So we should come to the details where it is necessary, but we should be able to move forward with assumptions.
Yeah, that's true. So I think again we are focusing on a new researcher who's beginning to do research, and one very good way to start your research, of course, is to go out and once you fix the area and the area is decided, go out and see what is latest happening in that area. Okay, go look at
not to reinvent the wheel.
Yeah, go look at recent conferences, the most recent conference, what is being published, what is being talked about, and then maybe you pick a paper which you like for some reason. And the first thing to focus on, I believe, is to be result oriented when you read the paper. Okay, how can I reproduce the same result that this person has? Is it even possible? If your conditions are not allowing you to do it, maybe you should not focus on that.
And there is a lot of advantage to that. You know, trying to reproduce a result. One, of course, is it helps you get familiar with all the nitbits of this thing. The other thing is maybe that researcher has made a mistake.
Yeah.
Right? Or not deliberately, of course. Hopefully not. But has overlooked. That's probably a better word.
Missed out,
right? And you probably have the chance to do that. Always remember, the creator has enough made sure that there are enough complexities in this world that every researcher forever can actually keep discovering something new. That's what I believe in.
Yeah, that is true. And actually, when you're result oriented, you'll also feel much better about doing your work, because you're doing something also. I mean, not just reading and reading and reading. So while many initial researchers fall into this trap that they need to know all the basics of every single tool or technique that's being used in that paper before they can reproduce that result. That's not really.
That's where I tell my student that look at the baby. When all of us were babies, we really did not say that I learn how to crawl and walk first and then only learn how to eat, or vice versa. I was trying to learn how to pick an object, how to eat, how to crawl, how to pinch, how to scream, everything at the same time. And it's not necessarily happening in a sequence. I think beyond a certain point, reading should happen as a parallel action rather than as a necessary thing.
That's true. So, and when you're result oriented, once you figure out how to get that result, you'll also know what tweaks you can make.
True. And also what material to read up further.
Exactly.
Right.
So that doesn't mean that you can ignore large chunks of the paper
right.
and then hope to get anywhere.
Right.
To be able to reproduce, you should know enough about the paper. The important aspects of the paper which help in getting that result, you should know, and you should know them very deeply. Only then you can innovate and make those little tweaks.
True.
So
actually, that clears a lot of
important.
haziness that exists in the initial stages and kind of brings clarity.
Yes.
You start seeing what your direction is, what material to read up, and your learning becomes more contextual. So you really know which textbook to pick up or which research paper to read, and in fact, how to read future papers also.
Right.